Okay, let's continue. Next session is compiling Postgres to WebAssembly with PGlite. The speaker is Sam. He works at Electric SQL and is the creator of PGLite project. It's all yours.
Thank you. January 2024, Jared Sumner, the creator of the Bun JavaScript runtime, he tweeted this: "I wonder when PostgreSQL will become a thing. It's an intriguing question. npm install Postgres, a tiny embedded Postgres inside your application." We've been looking at the same problem, but from a different angle. I'm a founding engineer at Electric SQL. At the time, we were building a bidirectional sync engine with dynamic partial replication between Postgres on the server and SQLite in the browser or your local application. But we were struggling. We had a problem with types. There's this massive impedance mismatch between Postgres and SQLite. So what's the solution to that? Well, Nikita Shamlagov, the Neon CEO, was advising us at the time about this mismatch, and he came up with a suggestion. Compile Postgres to Wasm so that we can sync from Postgres on the server to a Postgres embedded inside your client app. It would solve all of the type issues because you'd have the same identical data model both on the server and on the client. He had previously shared a proof of concept that had been made by Stas Kelvich, the Neon CTO, and Jared's tweet prompted me to take a second look, and Stas had cracked the first problem: forking. But first, what is Wasm? It's WebAssembly. In the simplest terms, it lets you compile your existing software into a format that can run inside a web browser, any JavaScript runtime, and some Wasm runtimes. It's a mostly single-threaded linear memory stack machine, and it's been used to port many libraries like FFmpeg, games and game engines, notably Unity, and it can be used to build full desktop class applications that run inside the browser. So Figma, which is a graphic design software, its entire rendering engine is running inside Wasm, inside the web browser. But back to Postgres and how it works. As you almost certainly know, Postgres operates under a forking model. And connections are made to the postmaster. It forks a backend process to handle each session. But Wasm can't fork. You can sort of do multi-threading with web workers and other tricks, but there's no concept of multiple processes that share some state and have signaling. So how did Stas solve that initial problem? Single user mode. So this is a special mode that you might know of that's part of Postgres that allows you to start the Postgres process as a single process, and it has a read line input and ASCII table output. It's super user only. Event triggers are disabled, both so that you can do disaster recovery. There's no IPC, there's no PG notify, very basic. And Stas's proof of concept compiled Postgres to Wasm so that you could run single user mode with a very basic terminal in the web browser. But you couldn't really use it for anything. You couldn't build an application on top of this. So we set out to try and make this real. What did we need to do to take this and make an initial release that people could actually use and build something on? So we used the Inscripton compiler toolkit, which actually is a project that predates Wasm. It was originally developed to compile C to JavaScript, but it's now the de facto standard Wasm compiler for the web. It's more than a compiler. It also shims libc and has a bunch of other tools to help port your code bases to Wasm. And getting Postgres to compile with Inscripton required a few hacks around unsupported features, adding a load of if-defs through the Postgres source code to disable code paths that just weren't going to work. The Postgres main loop, particularly in single user mode, is really simple. It's blocking on standard in, you pass in the ASCII query, processes it, and then it writes it to standard out, cycling until it exits. But that's actually one of the hardest problems to solve when you're compiling a C program to run in Wasm in a web browser. You need to pause that main loop. But in a single-threaded JavaScript environment, you can't do that. In Scripting, there's a solution to this called Asyncify. And it lets you await a JavaScript promise inside the synchronous C code. And it does this by unwinding the C stack. So it rewrites your program when it compiles it so that it can unwind the C stack, serialize it, and save it. It allows you to go away and do other things like waiting on JavaScript promises, doing some I/O. And then when you're ready, it rebuilds the C stack from scratch and continues. It's a little slow, but it works. And Scripting also comes with a VFS layer that allows you to use the standard POSIX file system APIs with backends for in-memory ephemeral file systems. You can persist to disk using the Node.js file system APIs. And in the browser, there's an API called the initdb API, and you can flush your file systems to that for persistence in the browser. So we use that for being able to save your database, your Postgres database. Output in single user mode is usually ASCII tables, but we hacked that so that it would output JSON, so that we could just JSON.parse in the browser to get back to usable JavaScript objects. So with all that, we got it working, and we wrapped it up into a JavaScript package. So you could just import PGlite, create an instance, run some queries, and that is a full Postgres running embedded inside Node.js or a browser. There's no Postgres server. It's all on the same thread as the JavaScript. npm install electric SQL PGlite. So with that, we set it free on the world and got a bit more of a reaction than we thought we were going to, and it motivated us to continue. Although, at this point, it was still very much a hack. If you pushed it a little hard, you'd find the cracks. It was slow and buggy, and some of the basic features that you would expect, like parameterized queries, just didn't work. So how can we make this production ready? More than that basic hack. So one of Postgres' little secrets that people outside of this room wouldn't know about, and one of the reasons it's so successful, is the Postgres wire protocol. It's what enables parameterized queries, type support metadata, notifications, cursors. And Postgres has this great internal abstraction for controlling where the output goes and the serialization of the output. So we use that to add wire protocol support to single user mode. And this enabled us to add parameterized queries and passing the columns that were returned to turn them back into the correct JavaScript types. But there was another issue. Asyncify is slow, really slow. It turns out unwinding the C stack and serializing it and trying to wind it back up again is not something that you really want to do. But we were only using it in that one place to wait on that promise on the main loop. So what do? We unwind the main loop. We can then came up with this scheme. So you encode your query as a wire protocol message, write it to a buffer, call it single interactive one function, which does a single iteration of the main loop, processing the query, writing it to an output buffer, where you can then access it from JavaScript. This gave us a 6 to 8 times speed up over using Asyncify. Don't use Asyncify. It's a bad idea. So initdb was something else that posed as a problem. Obviously, normally with Postgres, you have the initdb, which is a separate binary, separate command to bootstrap a database. But you don't want to do that inside an embedded environment. You want it to be automatic, or you want to have an API, a library for doing that. And initdb is also quite a complex multi-stage process. It first writes a bunch of template files to the data directory. Then it runs Postgres as a sub-process in a special bootstrap mode to actually build the data directory. So to solve that, we embedded initdb inside the main Postgres binary. When you start PGlite, it checks to see whether there's a data directory there. If there is, it just goes into single user mode. If there isn't, it runs the embedded initdb, which then calls the bootstrap main loop, which then does a fake sort of simulated shutdown and restart back into single user mode. So without having to use multiprocessing, we've been able to get from nothing to a full Postgres running as a single thread. We also wanted to make the developer experience around the embedded use case, particularly in the web browser, really strong. That's what who our users were, who we were targeting. So for that, we wanted to build something which we're calling live queries. React has won the framework battle on the front end. And if you're not familiar with it, it uses hooks to trigger re-renders of your UI when any of the state changes. So this is the experience we wanted to give developers. Write a SQL query inside a use live query hook and have it automatically run, re-executing the query when any of the underlying database tables changed that would impact that query. And to do that, we need a PG notify. So a combination of PG notify and triggers would allow us to build that feature. But PG notify depends on the inter-process communication, which we don't have in Wasm because there's no multiple processes. So we bypassed that whole part of Postgres and just pushed the notifications straight back up to that single connection that you have in single user mode. So what does this let you kind of build with this scheme that we came up with? This is an example app. It's called PGlite. It's an issue tracker app running a local Postgres in Wasm in the browser. All the state is local and saved in the Postgres database. All the queries are reactive and update in real time using PG notify. The filtering and sorting for the front end is all just SQL. And it even uses Postgres full text search, like there, for doing the local search functionality. It's a great demonstration also of what happens when you pair PGlite, Postgres in your application, with a Postgres server as your main data store, and use a sync engine to sync between the two. This AMP syncs in real time with the server and with all the other users, so you can see the changes happening. It's both the DX and the user experience that we wanted to enable. But we were not quite done yet. There was one more thing that makes Postgres the best database platform in the world, and that's the ecosystem of extensions. So we started with the Postgres contrib extensions, getting them compiled to Wasm, including the PGSQL extension. And that required making DL open work. So Postgres extensions are all shared libraries that Postgres loads at runtime. Wasm and scripting doesn't really come with particularly mature support for DL open. So we had to write our own tooling that would introspect each extension after compiling it, looking for which exports it was expecting from the main Postgres binary in order to ensure that we produced lists of exports when building the main Postgres binary so that the two would mesh together like a jigsaw puzzle. We compiled PGVector to Wasm, so you can have a full vector database for building RAG apps in the browser or any other JavaScript environment. It was particularly easy to port to PGlite because it's got no external dependencies. So some of the other extensions that we tried, particularly PostGIS, are quite hard to compile. That was a rabbit hole. But PGVector is a beautifully clean C code base, much like Postgres. So what have people built with PGlite since we let it free on the world? Supabase have created database.build. It's a AI database designer application that's running fully locally inside your web browser. You describe a database you want, and it will create it for you. You can iterate on the schemas. You can insert dummy data, and it can help advise on queries. There's Libchat, which is an AI chat app, much like ChatGPT. But your chat history is stored locally in the browser inside Postgres, inside a PGlite database. The search features are all using Postgres indexes and full-text search. Google have adopted PGlite to build the local emulator for the Firebase Data Connect product. It's built into their CLI, so you don't need to run a full Postgres when doing local development. And Prisma are adopting PGlite as the default database for local development. So they had the same type impedance problem that we had. Until now, it would default to using SQLite as your default development environment, and then you'd often go to production on Postgres. But they are imminently releasing a new version of Prisma that defaults to PGlite. I had 2 versions of this slide, and the other one would have been I'll be able to use hopefully tomorrow or the next day, but timings didn't quite align. But yeah, that lets you use Postgres without Docker. You can do your local development without having to have Docker. So we're really happy with what we built with PGlite. It's grown from a proof of concept a little over a year ago to a thriving open source project. It's been adopted by some of the largest and most exciting tech companies. We're seeing it used in embedded applications in the way that we originally intended it to be used when we set out. But it's also being used in CI and unit testing, reducing the need for full Postgres databases and speeding up test suites. You can fork a full in-memory Postgres in tens of milliseconds. So rather than having complex template databases and schemas to build your CI, you can just fork an in-memory state of a database almost instantly. We're also seeing it used as an alternative to Postgres in development environments, just like Prisma are doing. And there's also a massive opportunity for PGlite and in this embedded Postgres in AI coding assistance. These platforms like Lovable and Bolt, if you've not seen them, they allow you to design applications through a web app. And they run the code in a sandbox. But quite often you need a database to run that app against, often a hosted Postgres. But with PGlite, you could run that Postgres inside the sandbox, inside their development environment. So PGlite now gets a little over 500,000 weekly downloads on NPM, and we have got a little over 11,000 stars on GitHub if you count GitHub stars as being important. So what's next for the project? This image of the Postgres ecosystem did the rounds a few months ago. Postgres is eating the database world. There's now good solutions for OLAP, time series, graph databases, and many other problems where a dedicated database tech would have been used before. David's talked this morning about this in his keynote. Postgres is the one-size-fits-all database. But there's one place where Postgres is missing, and I think we're on the track to have the answer to that. Libpglite. Our ambition is that PGlite graduates from being Wasm to becoming an embedded library mode for Postgres. We want to make it native and portable and embeddable as SQLite, bringing all the power of Postgres and its incredible ecosystems of extensions to native apps. There's a lot to solve to get there, but there's much crossover also with other things that are happening in the Postgres ecosystem at the moment. The pluggable storage backend proposal would help enable us to build a VFS layer like what you have in SQLite, and the possible move to a threaded architecture, which we heard about from Thomas this morning, would enable embedding a libpglite inside a multi-threaded application. This is going to be a long-term project, and I'm determined to see how far we can get with it. And I want to work with you, the Postgres community, to try and make something like this happen. So yeah, I know you're all going to be getting hungry at this point. It's nearly lunchtime, but I just want to thank Stas Kelvich for creating the proof of concept that kicked off this project, and my colleagues Steph Paul and Tudor for the work they've done to make it real, and all the many other contributors from the community that have contributed to it. PGlite wouldn't exist without them. So please do check out PGlite. It's online at PGlight.dev. I'm around all week, and if you'd like to chat about its future, where we can take it and how we can collaborate with the wider community to make an embeddable Postgres a real thing, I'd love to chat. But I'd like to leave you with one final thought, and that's, what would you build with PGlite? What would you build with an embeddable Postgres? Thank you.
I think we have time for one or two questions.
It's fantastic. Very nice talk. One of the challenges with projects like this is always keeping up with community and currency. And so I don't know where you have, I won't call it forked, but where you have last synced from the Postgres master, and what's your strategy for doing that? Like you talked about needing to propagate a lot of defines. Do you see trying to push some patches upstream to make it easier to build without all those stuff?
Lots of questions there. So yes, we started on Postgres 15. We've been via to 16. We're now on 17.4. The intention is roughly that I don't think, at least initially at this early stage of the project, we're going to try and keep up to date rapidly, or even have multiple versions of Postgres compiled. We're not a big enough team to be able to maintain that. But the rough strategy is keep a main branch, or fork a new main branch every major version, and then merge in the patch releases as and when they come. But it does require a fairly sizable rebase every time a major version comes out. On upstreaming, I didn't really touch on it here, but there's actually a standard called WASI, the WebAssembly System Interface, and we've got the groundworks for what could be a patch set that would enable you to compile a standard Postgres to WASI using the WASI SDK rather than the Inscripton SDK. I know that's going to be a moonshot to get it into Postgres, because we'd be the only consumers of it, and I suspect there would be hesitance about adopting that. But it's something that we would love to have those conversations about, of what can be upstreamed and what else we can sort of do to help make these things easier.
Factorings that might make it easier.
Yeah.
Thomas will love to have to worry about Wasm.
Oh, actually, when I saw the blurb for your talk, it made me think about, what if we compile standard to WASI? Because I'm thinking about Wasm from the determinism standpoint, and I'm like, as a person who develops on like a fork of the engine, I was like, can I have like really cool simulated tests because I compiled on Wasm? So I think I would love to hear about WASI. Yeah.
Yeah, I think you could do stuff like that. So you would be able to, if you compile Postgres to WASI and ran it inside one of the Wasm runtimes, you would have incredibly deep observability and repeatability of those test suites. Yeah. There's still limitations. WASI doesn't cover everything in POSIX. It's not going to give you multiple processes. So there's problems to solve if you wanted to do that. But I think in time, the WASI standard will expand. Yeah, it's a long-term project, I think, that one.
You have said multiple times that Wasm doesn't cover multi-processes, multi-threads. Have you tried to kind of go to the WebAssembly people and talk, and maybe you could add it?
When I said there isn't support, there sort of is support for threading. So within the web browser, there's something called the Web Worker API, which allows you to have multiple worker threads, but they're not the same as operating system threads. And you've then got to use something called shared array buffers to be able to share memory between workers. And it's not a one-on-one match with what you would normally have. The compilers try to paper over it and make it work, but it's only very simple programs that kind of automatically compile and do work in that way. The motivation is there within the standards teams to get to something that is compatible with POSIX and is compatible with these things. Certainly on the threading side, multiprocess is something I don't think they have any intention of ever even thinking about, because as Thomas said this morning, why would anyone use multiple processes when you've got threads?